Welcome to Brain Vision.
Okay, so we have this block that slides among a curve that which sides are perfectly smooth. Okay, so when it slides through here, you can see there is no friction. Okay, and then it reaches a rough horizontal bottom that is here, this kind of shaded thing. Okay, it measures 30 meters and it has a coefficient of 0.2. Okay, we want to know if this block starts 4 meters up or above the rough bottom, where will what's the distance it will travel before coming to rest, and what is the total amount done of work done by friction. Okay, so we are going to start with the distance. Okay, so notice in this case we have something by conservation of energy. We know that potential energy times kinetic energy must always be conserved. Okay, so I know that this is, if this is in point one, that is 4 meters up, I know that the potential energy, okay, plus the kinetic energy it has here must be equal to, I'm going to put this 2, the potential energy 2 plus the kinetic energy 2 that it has in the bottom. Okay, I know, okay, that since it start or let's just assume it start from rest, so the kinetic energy in one must be 0, and I'm going to assume that this is at 0 height. Okay, so the potential energy in 2 must be 0. Okay, so I know that all the potential energy u is going to be equal, or it's going to convert to kinetic energy from point 1 and from point 2. Okay, I know that potential energy is the mass times the gravity, acceleration, the gravity times the height. Okay, and I know that kinetic energy is 1/2 of the mass times the velocity squared. Okay, so if I equal this, it's actually, you see I don't have the velocity, but I do have the height. Okay, so I know that the potential energy, which is equal to the kinetic energy, is equal to mgh of point 0.1. Okay, and this is 2 kilograms times the gravity. Okay, times the height, that is 4 meters. And if you make this calculation, you are going to see that the block has 78.4 joules of energy. Okay, and since energy conserves again, and no matter in which point between 1 and 2, this is the energy the block has. Okay, that is the sum of potential and kinetic energy. Okay, so it's also the energy that it has here in 2 when it enters the rough patch. Okay, so it enters here with 78.4 joules of energy. Okay, but this energy is going to be dissipated by friction. Okay, so that is why the block stops. Okay, so I know that the energy here, okay, is going to be the 78.4 uh, joules of energy it has at the beginning minus the work done by friction. Okay, because this work is what is going to stop, and this must be equal 0 because this is taking energy, but I want to know when the amount of energy done by friction of the work, okay, is the same as the one I had before, because this means the block has stopped. Okay, so this is when the energy, the total energy, is 0. Okay, so I also know that a work done by friction, okay, is remember, work is force times distance. Okay, And I know that this force is the coefficient of friction times the normal and times the distance. And I know that the normal is the mass of the block times the gravity. Okay, so I have that this is the work done by friction. So I substitute and I have 78.4 minus mu mg d. And this must be equal 0. And I solve for d because I want to find the distance. Okay, so d is equal to 78. When you rearrange all this, is 78.4 times mu kmg. Okay, and when you put values, okay, we know this is the value. We know that the coefficient is 0.2. Okay, we know that the mass is 2, and we know that gravity is 9.8 or 81. Depends on how accurate you want. Okay, and this is 20 meters. Okay, so the distance it travels through the rough patch before starting, or is 20 meters. Okay, so it stops around here now, the third part. Okay, so this is the first part. And the second part, the part B, asks what is the work done by friction? Again, since I enter with 78.4 joules of energy, then the work done by friction must be minus 78.4, okay, joules, because the friction takes away all of the mechanical energy the system had, okay, for it to stop. So this is the work done by friction.